So this is 5.2, number 37. Velocity questions are very important. On the normal AP testing years, you have 6 FRQs, and you always have an FRQ that you have to deal with velocity, acceleration, position. You have to know the relationship. The derivative of position is velocity, derivative of velocity is acceleration, and you have to know how to go backwards. The integral antiderivative of acceleration is velocity, and the antiderivative of velocity is position. So you have to know that relationship, and there's a lot more to know about those that we'll cover as time goes on. But we are given the velocity in miles per hour and the time of this car at specific times. And then we know our intervals from 0 to 2, and they tell us 2 and 4. Well, I'm going to just do 4. I'm not going to do 2, because if you can do 4, you can do 2. I don't want to spend the time, and I want you to peek at the answer, so I'll hide that. So let's look. If we graph this, I made a graph, and I'm going to go, every dash is 1/4. So that's going to be 1. That's 2. So that's going to be our scale. And I plotted those points. Now, they ask us to draw a smooth curve. Now, you look at this and you make an assumption. Some people, oh, I know what this looks like. Here is the velocity of the car. And that would be wrong. We actually don't know it. Wow, it's so laggy. I write and I watch the screen and it appears like 5 seconds later. That's how I know my internet's slow right now. Okay. It's impossible for that to be the velocity of the car, because this means the velocity instantaneously changed from one to another. That can't happen. Velocities don't do that. Velocities gradually change. So that's not what the graph looks like. We actually don't know what the graph looks like, but they ask us to draw a smooth curve. So this is my guess. This is my guess. It's going to slow down, speed up, slow down, speed up, slow down. This is my guess. There's my smooth curve. That's a total guess. It's a possible. Someone might say, nope, that's not what the car did. The car did this. Look, its velocity was crazy, almost stopped, sped up. Yeah, that's my velocity curve. It's possible. We don't know. Just to let you know. So there is my curve. They want to use midpoint sums to approximate the displacement. And here's what we learned in the last video. The area under this curve, if you take that area, in this case, it'd be the distance traveled. That's weird that the area of the curve is distance traveled, because if you take one of these things, this is velocity, this is time, and we learned velocity times time is distance. All right. So, yeah. Make sure you know the difference between displacement and distance traveled. That was in some of the questions. That was on the video I addressed. That's important. So what are we doing? We need delta x. Delta x is b minus a over n. N represents the number of rectangles. Why b minus a? Because I want to find, should I color this in? Should I? I'm going to color it. Okay, I'm going to go over the edges. Sorry. I don't have time to be perfect. And my pen's too fat. So I can't do it perfectly. I know I'm outside the lines. I was always a bad color, but that's the best I can do. So that area is actually the distance traveled, but we're going to use 4 rectangles to approximate that area. So the question is, how wide is each rectangle? Well, what do? We take this total distance here. That's b minus a to get that distance. You take that final minus beginning is the total distance, or total amount of time. But since there's 4 rectangles, we break it into 4 equal. So it's b minus a over the number of rectangles n. So that equals 1/2. So each of our rectangles will be a half wide. So I'm going to draw these out. My first one is going to go from here to here. That's half. My second one is going to go from here to here. That's another half. My third one's going to go from here to here. That's length is a half. And the last one's going to go from here to here. There are my 4 rectangle bases. Those are all 1/2 wide. So what is a midpoint? I will show you. The area is about, I'm going to take the midpoint of the first 2. There is the midpoint. That's the middle of the first rectangle. So I'm going to find the y value at that point, and that's going to be the top of my rectangle. So what is the height of that? The height is right there, which is the value of the function at, and by the way, this is 0.25. How do I know that? Because I chose each dash to be 1/4. So that's 0.25. So how tall is this point here? That point is a function at 0.25. So the height of that rectangle is a function at 0.25, and the width we determined was a half. So we know that is 1/2. That's supposed to be red. Red. Now I need the second rectangle, the golden rectangle. Where is the middle of this? I claim the middle is right there. So I'm going to find the height of the rectangle at that point. There's the height of that rectangle. There is my rectangle. Oh, by the way, did you hear that 2 angles had an accident? They crashed. You know what happened? It created a rectangle. Rectangle. See? Okay, that was your bonus for the day. So the second rectangle, what's the height of it? The height is the y value there, and this is 0.75 because that's every dash is 0.25. So it's going to be the function at 0.75, and the width of all these are half, so I'll do a half. The fuchsia, where's the middle of the fuchsia one? I claim it's right there. That's the middle, and that's at 1.25, and the height is going to be right there. So that's the height of my rectangle. So the height is going to be the function at 1.25, and the width again is 1/2. And the last one, the greenie, there's the width. The middle is going to be right there. So that's going to be my middle, which is 1.75. I get the height there. And that is my last rectangle. The height of that is, wow, it's so laggy. Keep watching that. It's going to be at 1.75, and the width again is 1/2. At this point, we just figure out these values. We'll look at the table. What's f at 0.25? Right there, 50. 50 times a half. What's the function at 0.75? Right there, it's 60. So it's going to be 60 times 1/2. And what's it at 1.25? 65, right there. So that's, whoa. That's going to be 65 times 1/2. And the last height is 1.75. That's going to be 60. So it's going to be 60 times 1/2. Now, if this were an AP FRQ, you would stop there. That is your answer. You are done. If you were to try to simplify this on an AP test and you simplified incorrectly, the point that you just had here is lost. You lose your point. Do not simplify. The basic rule, if an algebra student can simplify it, you're done. Don't go further. That's your basic rule for when to simplify. But you need practice. If this were an FRQ or multiple choice, you have to simplify this. So practice your algebra. Don't get lazy. So this is going to be half of 50 is 25. Half of that's 30. Half of that's 32.5. And half of that's 30. And what is that? 30, 60, 90, 90, 110, 115, 117.5. There you go. That is number 37 midpoint